For the design of the main reinforcement in the pile caps, there are two methods that can be applied, which are the bending theories and the Truss Analogy. For the bending theory, the pile caps are designed as an inverted beam subjected to bending and shear. As for the Truss Analogy, the force from the columns are transmitted by an triangular truss, and the steel reinforcement bar will provide the tensile tie force, as illustrated in this diagram here. For the span to depth ratio of the pile cap, which is less than 2, that means the span of the pile is relatively less in comparison to the thickness of the pile. Truss Analogy will be more appropriately representing the response of the pile foundations. Therefore, the Truss Analogy is used. Otherwise, when the depth of the pile cap is relatively small, the bending theory is used. In this chapter, we will focus our discussions on the Truss Analogy, as demonstrated here. This is the typical free body diagram for the pile cap foundations, based on the principle of Truss Analogy. When there is an axial load generated by the columns, the piles will generate reactions to the load. These reactions will generate resistance to the axial load, and all these loads are to be taken by the pile caps. Based on the principles of the Truss Analogy, the stress within the pile cap will appear as if a truss, where these two will be in compressions while this will be in tension. Since that the concrete is good in resisting compressions, the compressive load is taken by the concrete, and the tension here will be taken by the reinforcement bar. Based on these assumptions, we are able to determine the amount of reinforcement bar required in the pile caps. This can be derived from this free body diagram. Let's say now you have an axial load acting on the column S and N. The reactions of two piles will be equal to N per 2 and N per 2 each. And the distance between two piles will be equal to 2L as assumed, and the depth of the reinforcement from the top surface of the pile caps is considered as a D. Based on the analogical truss here, if you look at this part, this forms a triangle. The triangle will be in the form of D versus L. And it is assumed that the force generated within the truss here is proportional to the dimensions. That means you can use the dimensions here for you to predict the tensile force generating in the reinforcement bar. Make comparison of this. L over D, which is this, will be equals to T over N per 2, which is this. We arrange the equations, you will get this. You will need to provide sufficient amount of reinforcement bar in order to resist the tensile force. This is done by having the reinforcement bar multiply the design yield strength of the reinforcement bar needs to be equal to the tensile force, as written in this format. The design steel strength is given by this formula of Fyk divided by partial factor of safety of the steel, which is equals to 1.15. This derivation here is meant for the Truss model of two piles, which is this. This diagram here represents the pile groups of 2, 3, and 4 piles, and the arrangement of the pile in respect to the columns are given here. The A, B here represent the piles, while this represent the columns. On basis of the derivations, you will obtain the tension bars between the pile A and B is given by this formula. When there are 4 piles, the reactions per pile will be equals to n per 4. Go through the process of the derivations. You will get your tensions bar between the piles equals to this formula, which is half of this. In the case of 3 piles, the reactions given by the pile will be n per 3. Again, through the derivations, you will obtain T equals to 2NL per 9D. That means, in order for you to determine the amount of reinforcement bar for the pile group of 2, 3, and 4 units, you can simply substitute the formula here with the T here.